Hello, everybody, and welcome to today's presentation, Kubernetes Monitoring Best Practices, brought to you by Sysdig. I'd like to introduce you to our presenter, Eric Carter. Eric is Director of Product Marketing at Sysdig, focused on monitoring, alerting, troubleshooting, and security solutions for containers and microservices. He's been helping enterprises optimize and accelerate systems and applications for more than 2 decades. Prior to joining Sysdig, Eric led product marketing and management for the software-defined storage startup Hedvig, and has led sales and product roles at Riverbed, EMC, and Legato Systems. Eric holds a BA in Public Relations from Pepperdine University. And with that, Eric, I'm going to turn things over to you to begin the presentation.
All right, fantastic. Thank you again for that introduction, and I'll just go ahead and get started. I'm going to minimize a window here. There we go. So, yeah, our topic today is to talk about Kubernetes monitoring and some best practices around that, things that we've learned at Sysdig as we've worked with customers, I guess, I would say both large and small, but now more so on the enterprise side, and some of the things that we know that they have asked for and that they need around the Kubernetes environments that they're rolling out, so that they have visibility, so that they're able to do alerting, troubleshooting, and they, again, even down into the security side. So we'll roll through some things here in the next part here of this session, and then I do plan on kicking into a demo so that I can show you some of the ways that what we talk about in kind of the slide section can come to life in a product, which will be Sysdig Monitor, our product. So with that, let me go ahead and move forward. And thanks to everyone for attending. And again, if you have questions, please use the question box. So let me start out just by acknowledging, and this is going to be no surprise to you, the audience, but acknowledging this huge shift in our architectures and what we're doing to roll out applications. And it's really by necessity, because business today is moving so quickly. Everyone's got a digital business agenda, and the ways that we were doing IT in the past, or systems and applications that were serving sort of the business back end and so on, are no longer adequate, or no longer fast enough. And so we found ways to make a shift in application architecture so that things happen more quickly, both from an application development standpoint. I mean, think about how many times now we hear the word DevOps, and sort of this new modern way of architecting applications and rolling them out, continuous improvement, continuous development, and so on. And Docker emerged, and now Kubernetes has emerged really as a de facto orchestrator for these architectures, what we'll call cloud native, because we're able to use that to automate a lot of the infrastructure components that we need to have sort of coming and going based on the demands that we're facing, ebbs and flows of business, to be able to roll out updates, to be able to, again, just scale with capacity. So we're faster, we have more flexibility, and we move into this world of microservices where we also deconstruct applications. And so there's a lot of moving parts, yet I think in the end, the idea is all of those things help us to move faster. So what's the challenge that we face around monitoring? And we're going to get into that. Before we do, I wanted to take a quick poll here with you guys, and we'll push that out for you. So if you will take just a moment so that we can get an idea of where you are at in your Kubernetes journey. So you should see a pop-up on your screen. And this is giving you a few answers to pick from. If you're just here exploring, you're kicking around whether it should be Kubernetes, whether it should be Docker Swarm, or any of the other solutions. Maybe that's you. If you're using it in development only today, pick that one. If you're full on in production, assuming that you would also be in development, right? So you can choose that. If you have really no plans of using it, maybe you're here to learn about the technology, but don't have anything going on, or if you're unsure. So we give you a bunch of choices here that we'd love for you to participate so that we can take a look at the results. What it will do is give me an idea of who has joined up today and exactly what level you're sitting at in terms of using the solution. So why don't we take just another couple seconds here? Please go ahead and select your answers. All right, and whenever we're ready, let's take a look at the results. Aha, fascinating. Now this, I guess I shouldn't be surprised. If we're looking here, 60% of you are just exploring. So one of the things that I experienced this year, I went to DockerCon and had lots of conversations, again, with all sorts of different organizations. And there were a lot of folks that were just getting into the technology, even from a learning standpoint. So that looks like a lot of you here using it in dev and production, 13 and 13. So that's interesting that those numbers are the same, 13% for each of those. Not planning to use it and not sure 10%. So not planning 3%. That's interesting too, because there's that means a lot of you are figuring this stuff out with plans to use it. Okay, good. That's good table setting for me. That means that as you're exploring, hopefully some of the things that we'll talk about today will give you some things to think about as you enter this world and start planning how you're going to monitor the environment. So I talked just a moment ago about that shift in our application architectures and what's going on with microservices and so on. So when we kind of hone in on monitoring, what are some of the things that we find? Well, first of all, I'm calling it new technology. It's new to a lot of us in terms of using it. The containers have been around a long time. The containers are meant essentially to be a way to isolate things that we want to run in our environment and essentially have some assurance that this is going to run wherever I end up spinning it up, right? And so the idea is to have a container, have it run, in a perfect world, run a process, let's say like an Nginx container that's going to do some sort of web front end or load balancing for me, right? I might want to, that's the only thing I want in that container. And it's meant to be a black box. So if it's a black box and I'm not doing anything else inside of it, how am I going to see the performance and activity on the inside? It can become a challenge different than we've had in the past with virtual machines or even bare metal servers, which we'll look at in a second. So the question I pose is, in a containerized world, when you're not inside the container, how do you figure out what's happening? And then the architectures themselves, if you look at a full-on Kubernetes architecture diagram, there's a lot of pieces and parts. Now, it's not to scare anyone because essentially those things are well engineered and meant to work together. But this dynamic infrastructure that we're now rolling out, much of which I guess we're headed down to be microservices where we have different pieces of our application that are running independently, becomes complex to monitor because I'm no longer just looking at host A and how it's performing. I really need to look across my entire environment. And so how do I monitor that kind of an environment that's distributed? And how do I alert? How do I know that something's wrong? Because a lot of this is built for failure, meaning I can have nodes fail. It's not a big deal because my application is gonna keep running and get scheduled on different nodes. So again, how do I figure all this out? So that's another one of the challenges for monitoring. And last but not least is around just different ways that we're working with the environment, information spread across those environments. How do I identify bottlenecks? How do I identify what happened when something does happen? And that could be 10 times harder than it was in the past when we were thinking about this from a host basis. So not to mention that the ephemeral nature of containers. If a container that was having an issue has now been killed, do I have information to figure out what happened or not? And so that can become another challenge. And we'll talk about how we might solve some of those challenges in the Kubernetes environment today. What I want to do is start on the ground level. When we think about monitoring solutions, there's typically some sort of instrumentation that takes place so that we're able to collect the metrics and information that we're looking for and then have it displayed in our monitoring tool of choice. What we want to do here is just take a look at some past examples. And it's really to paint the picture that as we progress that doing things the way we've done in the past isn't necessarily going to work for us in our Kubernetes environment. So here's what I mean by that. When we think about the bare metal servers, I guess this would go, way back for some of us who have jumped into VMs and things like that since. But the bare metal server world, very straightforward. I'm going to run some sort of monitoring agent that has the instrumentation that I need, and I am off to the races, right? I'm seeing what's happening on that box, CPU, network, storage. I'm potentially getting inside the applications and looking what's happening there. So not a lot of overhead, works very well. When we split that out then into a world of virtual machines, and I think about the same kind of approach, I mean, a VM was basically our virtualized version of those bare metal servers. And typically we would go ahead and do the same operation, drop some sort of monitoring agent inside of those virtual machines, or for some solutions, at the hypervisor level as well. And, that typically worked okay too, because each one of those VMs has its own isolated machine, operating system, kernel, and so on. And, it just seemed to work for us to progress down that path. But now that we turn to this world of containers that are being orchestrated and coming and going, the idea of that isolation is broken if we try to do this same model, meaning if I try and instrument every one of those containers to have my monitoring agent or my monitoring logic and so on, I, at some point, am sort of committing the sin of having now something else that needs to be updated within that container, something that has nothing to do with the process that container is intended for. And so it's something that creates a challenge for some of the solutions that are out there, because if it's reliant on running inside of a machine of some sort, how am I going to be able to see inside those containers? And so we would not recommend, going down this path where you're actually putting monitoring code inside the container, bloat being one of those things. And what happens when things get revved in the software world of one versus the other, and you're turning containers over faster than you want to. So we started looking at this problem at Sysdig. And if we think about what containers do, they all share that Linux kernel. And now it's obviously Windows is coming to the container market as well. But that shared kernel experience, what if we could look into that part of the stack and figure out how to get our metrics from there? And so that's one of the things that I want to point out to here today as an ideal way in a containerized environment, in a Kubernetes environment, to actually get insight into what's happening from a performance perspective and so on. So if we think about it, all of these containers that I show on my screen here, Nginx, Redis, MySQL, and so on, they're all sharing that kernel, right? They're all isolated, but they're all sharing that space. So what if we could instrument at the kernel level so that when these containers come and go, that when they start talking and basically executing system calls of all sorts and types and types and sizes, wouldn't that be a great data source? And in fact, it turns out that it is. That monitoring at that level, we're able to see just about everything that's happening in the system, as well as communication down and through the network and infrastructure. And so from that standpoint, taking a page out of the container playbook by leveraging that shared kernel, we're able to get a lot of the information that we need, including seeing what's happening on the inside of containers. And how do we see that? Well, because whenever that container starts to talk and do its thing, we're actually able to see the processes that start up and identify what it is that's running inside that container and so on. So we can see all of these good things from a single point. And you saw in my animation here, I dropped in this extra container. So what that means is that now, instead of trying to run an agent in every single one of these containers, we can simply run something per host inside a container itself that collects that information and provides it back to you. And it might also provide it back to an aggregation service, which is something at Sysdig that we do. out into a cloud or even in an on-prem type of backend or so on. So this becomes an ideal way now to instrument for Kubernetes and Docker environments, and something I'd encourage you to check out. And so looking at this a little further, when we think about best practices in this kind of mode for Kubernetes, what do I do in order to roll out such a instrumentation model in a Kubernetes environment where I want to be quite hands-off? Well, one of the things that we find Kubernetes does quite well is that you can essentially define and use daemon sets to deploy this kind of instrumentation model on any node that comes up in your Kubernetes environment. Well, what's good about that? What's good about it is that it's kind of a hands-off mode of making sure that every new host that shows up is ready to go, is providing metrics back to you, is doing the things that give you the visibility that I think most of us want to have in these new environments. So automating rollout is good, ensuring monitoring is good. I've talked to a few customers who have used other solutions where, because Kubernetes makes it so simple to start, and roll out a new application, I'm spinning up additional resources and things like that in my environment. If we forget the monitoring angle, then suddenly we have things that are going on in the environment that are unmonitored. And typically when we find out that they're unmonitored is only after there's a problem and someone says, can you help me figure out what happened? You say, well, no, because we didn't even know that was in the environment. So again, best practice here is if you can deploy your monitoring intelligence using daemon sets into your environment, that makes it sort of happen automagically. And then you'll be able to see that stuff dynamically as things show up in your environment. Now, one of the things that in this collection process that we take pretty deep advantage of at Sysdig, and I would encourage you all to use as well, is this concept of labels and tags. And we'll look at this from a couple different angles as we go through here. But when we take advantage of these tags and labels, which are essentially descriptors or ways to mark or identify different pieces, whether it's the application and the container itself. Kubernetes has labels that are associated with the different components that it has. Cloud providers have tags that we can use. What it does is when we are trying to look at different aspects of our environment, we can actually say, show me for everything that's labeled Cloud Provider Availability Zone West, everything that's out there and running, and I can go further, right? As you see in my example here, add additional tags and be able to get the information presented back to me sort of at a much more granular level, what we like to call slicing and dicing, right? And so if you're not providing descriptive tags inside and labels inside of your environment, you probably should, because it's only going to help you down the line. And it's something that we pick up and give you back essentially for free at Sysdig, so that you can explore your environment, group your environment, and I'll show you this in the demo, but in just about any way that you'd like. And when we think about this idea of being able to explore our environment, as we move from a host-centric or a VM-centric environment into these dynamically provisioned environments, we might end up with something that looks like what's on the left, right? Which is a host that's running, if you think about the different colored boxes being parts of an application that are scheduled across different nodes in my environment. Obviously, I can't just look at the top left host and figure out how dark blue box application or service is running. So how do we do that? Well, one of the things that you should look for in modern monitoring tools is the ability to tie in, not just with hosts, not just with Docker and containers, but also with the orchestrator itself. Why? Because there's a wealth of information about the construct and the organization of your environment that Kubernetes has, that if you take all of the metrics, and again, all for Sysdig being auto-tagged with the information that's associated with that, and then take all of this detail from Kubernetes as to how those things have been spun up in the environment, and so on. That gives us the ability now to say, show me how dark blue service, in this case service 2, show me the performance and health of that service wherever it's running. Let's forget about the hosts or the nodes at the physical level for the moment, and just show me in aggregate what's the experience like with that versus 4 versus 3 versus. So it gives us a way now to give you a more logical view versus a physical view, and I'll also show you that inside the demo. So as you're looking at monitoring tools, I would highly recommend that you explore the Kubernetes integration for those of you who are going down the path of Kubernetes, so that you can have this kind of logical view presented to you in a way that makes sense, and you're not trying to piecemeal it together after the fact. By the way, at Sysdig, this is what we call service vision. Container vision, the ability to see containers. Service vision, the ability to present you that at a service level. Now, there are obviously a wealth of things available from a metric standpoint, and I'll show that as well inside of the demo, but there is this project that got started within the Kubernetes project itself that's called Kubestate Metrics. Well, one of the challenges that these folks were out to solve was, can we provide a source of information that helps the users of Kubernetes understand the state of the different pieces and parts of their Kubernetes cluster? Now, contrast the state with the health or performance. So performance would be more like, what's the CPU being consumed, how much memory is being stolen, and so on and so forth. Whereas the state is more like, hey, I asked for these pods to be scheduled. How many are waiting for nodes onto which to be scheduled? Or do I have enough pods compared to what I've spec'd out as my desired pods, right? Are enough available right now in the environment or not? So all the questions that you see here, about resources, the state of what I've put out there, do I have enough nodes ready? Are enough of them available? Am I out of disk space? So that's less about performance and just, am I, going to run into a brick wall here shortly? So Kubestate metrics are awesome. And it's, again, something that you should look for as another, what I'll call dimension into monitoring Kubernetes that you're going to need in order to get an idea of what the state of your cluster is. Because when something doesn't look right, now you have an opportunity to go solve that before it impacts anything in production. I am experiencing a slowdown here. Give me just a second. Can you let me know if you can still hear me out there?
I can hear you great, and it looks like everyone else can still hear you too.
Okay, good. It looks like PowerPoint has decided to go away for a second. Let me just see if I can solve that while we're chatting here. What I can do is just jump right into the demo if I can't solve this problem. Let me force quit that real quick. All right, not responding because I just want to show a couple more things. So, all right. All right, we're back. Let me explore down in here, get back to where I was. Yeah, a couple more things to cover before the demo. I did want to talk a little bit about two additional topics, and then I'll be able to show you that. Alerting and troubleshooting. Just really quickly. So obviously, when we're looking at things like metrics, We want to have pretty dashboards. We want to have the ability to explore those metrics and so on. But we also don't necessarily want to stare at a screen all day. So where alerts come in handy is just basically automatically looking for conditions for you. And if again, going back to how we have been doing it, a lot of times alerts have been focused around things like host resource metrics, and those are really good actually, because obviously even in a Kubernetes environment, host resource metrics will come into play. But typically something goes off the charts, and then we start reacting. And keep in mind that in a Kubernetes environment, just because one host is having an issue doesn't necessarily mean that anyone else is going to experience that problem, because we can self-heal our way around it, so to speak. So, but host metrics are still important. It's something that you're going to want to have at your fingertips. Container resource metrics, also very useful. Obviously, we want to know if my Cassandra containers are suddenly consuming way too much resources. In these monitoring tools, we can actually show you that information and sometimes give you an idea whether you've undersized or oversized, and in terms of the way that you're scheduling your containers. Also very good. Application metrics, even better. Now we're getting closer to the user experience. And so what I'm thinking about is, do I alert on hosts? Do I alert on the container? Do I alert on the application metrics that I'm getting? I may choose to do any of these things, but one of the things that we're finding in a Kubernetes environment, again, because of the way that it does automate things for us, is what if we alert on service-oriented metrics? Because it is going to be closest to the user experience. So when I'm monitoring the service as a whole and how it's behaving, that's going to give me an idea over there how the user is experiencing my application versus any individual container, any individual application component, or any particular host resource. So this is something that we would recommend, that it's going to be the most proactive in helping you see problems as they develop, real problems as they develop. And obviously it's going to be helpful for the end customers, but also internal. So developers are going to want to know if you're seeing some problem with the service, because then they can go iterate on the code potentially and fix that. So it's good to alert on the aggregation. It's good to alert around application-specific metrics. And it's good to set alerts so that they scale with your environment. So if today I'm running 4 pods of my application, and tomorrow I'm running 8, I don't want to have to go in and manually assign to 5, 6, 7, and 8 those alerts. I want to be able to have that alert automatically scoped, is the word that we use at Sysdig, scoped for the new stuff as it comes along in the environment. I may choose not to do that, but it's an ideal way to go about it. And we'll show you that today. And last but not least, I just want to touch quickly on troubleshooting. And troubleshooting is beyond seeing that there's a problem, identifying it on a chart, on a graph. It's like when that problem happens and potentially the containers are no longer running, how am I going to determine root cause? What I see is a lot of customers do use logs for that. I put the kind of snarky, if you have them. Sometimes those logs are not there or not available. And sometimes they're in a completely different system, so that now I've got to go over there and try and figure out what happened. But it does work for that purpose when things go awry and you need to kind of piece together the picture of what happened. You can also use something called capture files, and that's something that's built in to our open source tool at Sysdig, but also into our commercial tools, which are essentially an ability upon alert to collect all of the things happening on the system at the time of that alert, and then put those down into a file that you can interrogate after the fact. So I can look at things like network activity, what were the containers involved with the problem, what were the commands that were issued, and I don't lose any of that stuff. Even if the containers are now killed or gone, I can actually have the information that I need to go track down the problem. And so a couple different ways that you might want to explore as you're looking at deeper level troubleshooting in and around your Kubernetes environments. So that's a lot of different topics and things for you to think about just in terms of solving the monitoring problem for Kubernetes. Let's not call it a problem, the opportunity. that you might want to dig into some of these things as you're selecting tools to use. So what I want to do now is go into a short demo. I'm looking at my time here, looking okay, I think. And what we're going to look at today is our commercial product at Sysdig. What I want to do is kind of take you around the solution, but also show you some of the use cases and how it is being used for Kubernetes environments. Where I'm starting, so this is our default sort of demo environment at Sysdig. We've got some nodes that are running. I believe some of these are Amazon. We've got some on Google as well. And when we talked a little bit earlier about auto-discovering the environment, what's interesting about putting that instrumentation from Sysdig out there is we immediately start listening for those system calls, and boom, you'll immediately get views of your environment that you can start exploring, and we start picking up these metrics. When I also talked about the ability to pick up labels and tags and potentially looking at your environment, not from a physical standpoint, from a logical standpoint, what we're looking at here is that representation. Essentially, you're seeing something that looks like HTOP or whatnot, right? Which is giving me a set of details around my environment, and you can customize these, but this is the things we typically look at: CPU, network. So I have an idea at any one of these given. I am looking at the physical host at this point in one of these hosts, exactly what's happening, and we're turning them, yellow or red depending on thresholds that have been preset in the environment. But if you look, I'm actually scoped by host name and container ID. Scoping means simply that I've grouped this environment to show me the host and what containers are running on them. It's interesting, but potentially not super useful for a couple reasons. One, these containers all belong to potentially a different service. Remember, we talked about seeing things more at the logical service level. So as an operator, I may not quite understand that 9B757627F3AA belongs to that. What is that, right? Now, a couple ways you could solve that. Remember I said we pick up these labels and tags, and you're going to want to use those to see things in different detail in your environment. I can actually, one of the ways I like to do this here is to say, well, show me instead the container. I could do image or container. Let's just do container name and see what that tells us. So what we're going to see is almost the same view, but now I do have some more information beyond the ID to say, oh, well, this is my Java app. That's what that is. And this is my WordPress and so on. So I'm still seeing these things broken out by physical environment, and this is good. But what if we can take the information that Kubernetes has provided us and create a different grouping and have that as our day-to-day view? So when I'm talking about grouping here, what I'm talking about is, why don't I look at my environment instead from the logical hierarchy of namespace, deployment, pod, and container? And in this view that we call Explore, now I can actually see roughly here that namespace is the equivalent to my service or my microservice. So I can see that my Java app has Cassandra, Java, JClient, Mongo, Redis, all as a part of that. And then in parentheses here are the number of containers that are running for that. So Java, I have 2 containers running the actual Java app. I've got one running a database for me on the back end. And then if I want, I can see again, as I open these things, this particular details of my CPU memory by all the way down to the container. I could see it rolled up. I can drill down. And that's actually can be super helpful when we're looking where exactly is the problem that I'm experiencing in total. And so we give you this ability to scope your environment in just about any way you want to. And there are a bunch of views out of the box. We'll actually auto-discover your environment anytime those agents are installed and you log into the system. So we've discovered and shown a scoping by AWS. We can show you by Kubernetes, which we looked at. We can look at just the containerized apps themselves. And what that does is give us the different applications that have been scoped by container image type. I've got Kubernetes running. If I had things like Mesos, Swarm, Marathon. I could actually show those as well, but we don't have those running here in the demo environment. So one of the things that all of this information, the picking up of the details at that kernel level does, is provides us this rich set of views, because we're automatically seeing and organizing your information, because it's all available to us through monitoring the system calls across that environment. One of the things that you could do then is, because it's clear from that instrumentation who is talking to who, one of the things that becomes available to you that I'll show here is, let me go into a view of topology, is immediately out of the box, right? We're going to be able to show you things like a map of the environment, right? And that environment, I can zoom in on different namespaces. That's what each one of these things is. So let's zoom in here. This is my example Java app. Let me actually scroll in. So what I'm seeing is the namespace of that Java app, right? And I know that because if I click over here, it'll say, hey, you're at the namespace level. I can actually see then inside of the next level here, which is my deployment. And inside these deployments, remember we saw that we had a couple of containers running. Well, here's my pod, my Java app pod, that inside that pod, I've got a Nginx container running. I've got a Tomcat container running. And guess what? These are all the folks that are talking to each other. So imagine being able to see now this information and identify, how are we doing this? You're not telling us, hey, this is talking to that. Here's a map of my environment. Make sure you're monitoring these connections. We're actually able to see that stuff automatically out of the box for you. And in this view, we're looking at response time. So if I have a user that's reporting something slow, I might come in here and look immediately to see, oh, if there's a link that's actually being saturated, for instance, and the response time slow for that reason. And it gives you a nice way to actually look at your environment in total, and then to drill in on any particular thing that you want to. You know, there's an Istio namespace with all of its different pieces and parts. So that's one thing that folks find useful. I love the stories I hear. Some folks have installed the agent, started monitoring, and immediately start seeing hosts that should not be in the environment. And, you know, we're supposed to be in development that are now sitting in production. That's one real world brute force use case for this particular topology mapping that works pretty well. So again, just one of the aspects of things that you can do because of the new instrumentation model. What I want to do is take you through a couple of things that you should probably be looking at that I already mentioned earlier in the slide. So when we look at the different pieces of our environment, we might want to, again, decide to look at Kubernetes state so that we know how the environment's doing overall compared to what my desired pods are, the number of deployments, replica sets, and so on. So why this is useful is because you may want to know, for instance, that pod restarts are happening, right? And because when pod restarts happen too frequently, what does that mean? It could mean degraded service for your user. If you look, what I'm looking at is this Kubernetes state information for my entire infrastructure. But what may be more important to me is, as an application owner, I might want to just look at the Java app. And I won't show you this in the demo today, but we actually have the ability for you to create a demo, a Java app team who has only rights to see the data, metrics, and things from that Java app namespace. And for instance, that team would be able to look here at the state of Kubernetes and the name, all the different piece parts to identify whether things are going as planned around their application deployment just from the state of Kubernetes standpoint, right? And things look all right, but in each one of these things, I might have some alerts and warnings that I'm getting. And these alerts and events that are coming are also getting picked up through that very same instrumentation model. So you'll want to keep an eye on different alerts that happen in the environment that are triggered by things not meeting what you've set up in terms of how you wanted things to run in your environment. So very important for that. One of the quick use cases I wanted to show you as well that's very useful is anytime you roll out a new service, it might, it's time to keep an eye on that service. Why? Because it's new, because it's something that obviously if you've invested time, effort, and money in, you want to know exactly what's going on. So one of the things that, that there's a term in the industry called golden signals. And so when you're working with your Kubernetes environment and rolling out a service, and again, we're looking specifically at our Java app here, there are some metrics that really give you the first level insight into how things are going. Those are response time, request rate, error rates, right? So we want to know, what's the response time that's being experienced by my users? Is it within, the latency that I'm expecting? So let's see here, the Java client is 41 milliseconds. Is that okay or not okay? That's going to depend on you. But it is something to keep an eye on for anything that you're rolling out, and even over time. So golden signals are those golden metrics, those things that you want to know in and around your environment that will give you an idea if things are going well. Request rates, obviously that's going to give us an idea if my new service is so popular that it's being hammered, or is something going amiss in terms of errors in the environment. So we're able to show you all this, again, being collected from that single unified data source, and help you understand what's happening. And that goes beyond simply just looking at the service from these particular panels that we're seeing here, but you can also get slowest endpoints. What are something that I might need to dig into? My test servlet, maybe that's okay if that's slow, right? Or most requested endpoints, it's something I may want to scale up my resources on, and so on. So golden signals becomes a good way to keep an eye on things. Now you may say, well, look, you told me that this environment has Cassandra and other things in it. What I think is the problem is with my Cassandra container. So obviously we want to switch to a different view because now we're looking at a specific application component. So what I can do is look at a Cassandra overview instead. And now I'm picking up automatically, in this case with Sysdig, some of the same type of information, write requests, read requests. So if someone picks up the phone, or probably these days, they don't do that anymore, probably issuing a Slack message or something on that order, and things are not going well, boom, you could start digging into a particular application, right? And on any one of these particular measures, we talked about alerting. One of the things that you could do is alert. And for any of these metrics, you'll want to be able to create an alert to look for the behavior that's not desired, right? And so maybe my metric is greater than, so I'm looking now at the write count, and if it's, let's say, let me find the right measure here that'll show you. Yeah, I won't get an alert anytime soon for that, but let's say, I can tolerate 2 but not 3, so I can set that here. And right now what we've got is this scoped against just the Java app and the Cassandra component of that Java app. I could actually, remember what I said earlier, I could actually say, well, I like this alert for any Cassandra running in my environment, right? So what I could do is turn these off and scope this thing now against my entire environment instead, right? Everywhere. And so now any Cassandra that rolls into my environment, I'm actually going to have this same alert apply against it. And then I can get notified by any number of channels, Slack, PagerDuty, email, VictorOps, and so on. And I'm good to go. I don't need to look at a screen. I can get a notification when something bad is happening. And alerting is something key in a Kubernetes environment that you'll want to look for. The last piece here to show you, and then we'll go into the Q&A session, is around that troubleshooting. One of the things that we allow you to do that I mentioned earlier is to create this capture file. So at the time my alert fires, let's say I've hit the threshold, right? Oh, I'm alerted, and I want to be able to have this capture file created so that now if my containers are gone, the pod has been destroyed, and so on and so forth, I'm going to be able to have some information. So that information can become very critical to quickly finding issues in the environment. So capture files are nothing more than this. They're very powerful, but they are something that records system data. So what I did just then is I moved over to this capture area. I've got a bunch of them here that have been created. I clicked on that capture file. Why did I click on it? Because I want to open it to get into deeper troubleshooting. And when I clicked on it, that file opened into something called Sysdig Inspect, which is simply a UI for exploring that file. This is an open source project, by the way. You can go out to our GitHub and pull this down. But why I'm showing you this, and we won't go through the workflow, but why I'm showing you this is because this new world of Kubernetes, there's a lot of things we might want to look into when we have something that's not running the way we want. The wealth of data that we're able to capture here is going to give you the information that you need. Just look across the top here. So there's general things like what were the processes that were running when this happened? What were the running containers? What were the files that were being touched, accessed in and out? What was the network activity? All the way down to things like commands, performance data, and even infrastructure, right? If I've got containers that were destroyed in this particular problem, I've got containers that died, and containers that keep starting, what happens is I have this information that's a 15-second capture file, but it looks like something bad is happening inside of this particular space. So I can actually even jump down into that particular slice, and from there determine things like, okay, well, let's look at what was the containers or the containers involved. Oh, it's my Nginx. Something bad is happening here. And from here, we can go through and look at the processes that we're running. We can look at the errors, and so on and so forth. So I keep wanting to use the phrase smoking gun, but it's better than a smoking gun because it's actually sort of a DVR replay of what happened, right? So you can actually see the bullet coming out of the gun. And that, I think, is a valuable tool set in this new world of Kubernetes. So just give you some idea of the things that you want to look for: the ability to pick up information more seamlessly and automatically than having to load agents into every container that you're running, the ability to get labels and tags so that we can explore our environment in a deep kind of way and pick up metrics that might be, that's one thing I didn't show, but there's just a wealth of metrics that can get picked up, and you're able to look at those, everything from standard metrics to Prometheus metrics to JMX and StatsD. So system calls never lie. They are a good source of information. You want to be able to look at things like kube state metrics. You want to be able to have things like dashboards. We looked at a few of those, right? But you'll want to be able to have different abilities to build your dashboards and so on. And you'll want to be able to alert and be able to troubleshoot and have that information at your fingertips. So a lot of things to consider, not just when you're looking for tools, but when you're looking at how to best analyze your environment. And I hope this was helpful. And I think I will conclude the demo at this point. And let's go ahead and push toward the end here, where we'll look and see if we have any questions.
Awesome. Thank you for the great demo and presentation. Everyone, if you have any questions, please post them into the chat panel so Eric can get to them as soon as possible.
Yeah, thanks so much. And I'm just taking a moment to have a sip of water here. And what I'll do is open up my panel so I can see what's out there. Give me just a moment. All right. So one of the questions we got is, does this work with Kubernetes versions like OpenShift or Rancher? And the question is, or not the question, the answer is, yes, right? So we have certified across the things that we're doing here, and kind of the concepts that we talked about are applicable across Kubernetes that you would download from, GitHub, from the OpenShift deployment of that. We're doing a lot of work with Red Hat. We love Red Hat. Rancher, love the Rancher folks. Pivotal, and so on and so forth. There is quite a lot of activity around Kubernetes from different packaging and so on. It's something we did this Docker usage report this year, and we got a snapshot into what folks were using. And it was effectively, number one was off-the-shelf Kubernetes, but also OpenShift Rancher and so on. So good question. Those things all are applicable. There's another here that's around where this data is then collected. I'm assuming you're talking about with Sysdig, so I'm going to answer specifically in that mode. We offer the ability to collect metrics, your metrics for you, and host them in a cloud service. So we can call that Sysdig Cloud, Sysdig SaaS. We also realize that that there are some organizations that say, hey, we want everything, including our metric information, event information, inside the four walls of our own data center or potentially our own private cloud, whether that's the private Amazon or something like that. So we offer an on-prem version as well. So what does that mean? That means the agents are out on your nodes, and that means that those metrics are all collected. They're all being monitored up to the second real time, sent back into the cloud or into your own backend, where you then have that UI view. The UI view is what I was clicking through, and that's how that works. Sorry, I'm just looking at some of the other questions. Some very specific Sysdig stuff. Do we run one Sysdig agent container per host? Yep, that's correct. It's one per host, not one per container or so on, like a sidecar, but actually just one per host. And that means that it's pretty lightweight. Usually the question I get at this point, which might already be in the chat window, is how much resource does that take? What we typically see is somewhere in the range of 3% of the resource of the system. What we do is we have a throttling mechanism that will basically start dropping some of the data points, meaning instead of 1 second granularity, it's going to be 2 or 3, right? So that we're conscious of the resource utilization that we have, but can still offer you what effectively is giving you real-time information, right? And so, good question. A couple of other ones here, I think, centered around some of the last stuff I looked at and talked about. That is, can we capture application logs? And there's what I would think is something a little bit similar. Can Sysdig be integrated with Splunk? We actually love Splunk. We love the logging side of things. We find that most customers still have that, and some are actually using what we're collecting and sending that off into their logging system, Splunk, Elastic, and whatnot. And so what they get is they get sort of the more real-time view happening with Sysdig Monitor and the Sysdig toolset, and then they're getting their post-mortem or forensics view of things sort of after the fact that they could do with Splunk, and that might be more around business planning and so on and so forth versus the real time. And can we capture application logs? We certainly can. When those things are we don't capture them all day, every day, at all times. But if that's available and being sent across that kernel at the time of an alert or an error, we're going to capture that information and present it back to you in that capture file. And so for the span of time following the alert, we will have that information for you. And so that's important to note that we aren't a logging solution per se, but do have that capture facility. There's the on-prem, off-prem question again. We offer both. How is this different than Wavefront? That's a great question. I am not familiar with Wavefront, so I'll have to punt on that one. Maybe that's something we can follow up with, and I'll have to have a look at that. That's very good. Let's see if we have any more. I'm happy with those. And we're getting close to the top of the hour in any case. So I would encourage you, if there aren't any more questions, or if we didn't get to yours, we'll try to after the fact. But I'd encourage you to go jump out on our website. Any of the pages you're on, by the way, you can click try it now and get off to the races. Essentially with the cloud backend, and it's super simple. I didn't show you that today, but often on these webinars, we'll actually have a blank sheet of Docker paper, effectively put our agent in, and boom, within 5 seconds, you're seeing all the metrics and everything show up. It could be that easy for you to try, both from a monitor standpoint. We also look at this information from a security viewpoint. That's what Sysdig Secure is. So if you happen to be part of a security team, I would encourage you to take a look at that. That's all about now everything from securing from the time you're developing all the way through runtime. So the ability to do monitoring of security incidents in the environment, less from a performance standpoint, more from a security standpoint. So very, very effective. So look at that. I would encourage you to reach out to us if you have any more questions, and we can take that from there. But I appreciate your time today. I took nearly the whole hour. That's rare these days, but I thank you for your attention. And so I'll hand it back for the close.
Awesome. Thank you so much, Eric. Thank you for the great presentation today. I'd also like to thank today's sponsor, Sysdig, for providing the DZone audience with a great webinar presentation. And lastly, thank you to everyone who joined us for today's presentation. We hope you learned something new today that will help you in your developer career. Have a great day, and we'll see you next time.